So in this lecture, we discuss on Martingale. So what is Martingale? Martingale is not actually Markov chain. It's a stochastic process. Say it's not but it's very close to some Markov chain. So what is Martingale? So definition of Martingales is consider a Markov chain having state space say 0, 1, dot up to d, and a transition function p such that this happens. Some y equal to 0 to d, y into p xy is x. So a special type of transition function such that sort of expectation. It is like sorry, it is not 0, it's x. Sorry. So start from x, go to the y, and multiply that probability with y. That is again 0. So it's say start from you are starting from say 0. So then starting from 0, actually you can't go anywhere. 0 is the absorbing state. Because starting from 0, so say if so this implies actually 0 and d are absorbing state. Why? Because for 0, what happened? The equation is y equal to 0 to d, y into transition from 0 to y is equal to 0, but all the probabilities is 0, sorry, all the probabilities is greater than or equal to 0, and y is also greater than or equal to 0. So it's non-negative terms. Some of the non-negative terms 0 means the all terms are 0. Some of the non-negative terms 0 means all terms are 0. That means what happened? That means for each y into p0y is 0. So if y is 0, then p0y is 1, and if that implies actually y into p0y is 0 for all y. So for y equal to 0, then p0y is 1, and other for y equal to 1, y equal to 2, that p0y is sorry for okay, that's right, for y equal to 0, and this is 0 for y not equal to 0. So this is, so that's why the 0 is the absorbing state. Similarly, d is the absorbing state. D is also absorbing. Why? Same idea. Say for it is d, x equal to d, transition from d to y is sum is d. Now you just write this as y equal to 0 to d minus y into probability of d to y equal to 0. Now again, this is all are non-negative. D minus y is non-negative. D minus y cannot be negative because d is from 0 to sorry. Y's cannot be d minus y cannot be negative because y is from 0 to d. So that's again implies that d minus y is 0 for all y. So that means for d it is 1, and for other value it is, so for d it is 1, and for other y other than d it is 0. 1 up to 0, 1 up to d minus 1. Now we have a result that expectation of xn plus 1 given that x0 equal to x0, x1 equal to x1. In that case, xn minus 1 is equal to xn minus 1, xn is equal to xn or x, The last is x, and then what is the in the nth step it is in the x. So what is the expected value of the next step? What is the expected value of the next step? Given that the previous steps, previous thing is given, and this nth step is x. So what is that? It is just somewhat y equal to 0 to d. So xn plus 1 can be from 0 to d. So xn plus 1 value can take y is 0 to d. So the probability of xn plus 1 is the definition of expectation. So any random variable, the definition of the conditional expectation, x is just x into the probability of that x equal to y given whatever is given. So this is x0 equal to x0. But since the Markov chain, we just forget this up to n minus 1. So it is just a probability of xn plus 1 equal to y given xn equal to x. That means it is just transition probability from x to y. Now we assume that such in that case we assume it is x. That means Martingale is the idea is this. So if you in n step in x, the next step, the expected value of the next step is again x. It can be go left side, it can be go right side, but the expected value is again x. If you stay in 3, your expectation value is 3. Like 0, if it is 0, then your expected value is 0. You can't go out the right side. You always you have to, that's why 0 is the absorbing state. But if you in 1 say, you can go to the 0, you can go to the 1 in the next step, but the expectation is just 1. So this is sort of conditional expectation of n plus 1, given that in n plus 1 step, given that the xn, the nth step is x. So Martingale is a sequence of random variable. This motivate the definition of Martingale. Now the definition of Martingale is a Martingale is a sequence of random variable such that expected value of this. So this is a definition for a Martingale. So Martingale is a sequence of random variable x1, x2, xn, x1, x2, xn, such that the expectation is x. So it may not be Markov chain. If it is a if xn is a Markov chain with that property, that summation y equal to 0 to d, y probability of x from x to y is equal to x. If that is given to us, and it is said that it is a Markov chain with the special property, then it is a Martingale. Every Markov chain is not a Martingale. Martingale with that property, Markov chain with this property is a Martingale. Again, every Martingale is not a Markov chain. It is not that this is the only example of the this Markov chain is the only example of the Martingale. There are several examples of Martingale which is not Markov chain. But the idea of the note is Markov chain may not be that Martingale may not be Markov chain. Martingale may not be Markov chain. Eventually, Markov chain may not be Martingale. If it is not equal to this summation is not equal to x, then it is not a Martingale. It is a Markov chain, but not a Martingale. But there are other examples where Martingale, but may not be a Markov chain. So idea of the Martingale is if you in the nth step somewhere in x, whatever the previous step, whatever the previous situation, the next step, the expected value of the next step is x, where you are now in the present step. So future, the expected value of the future is just the present. That is the idea. That is called Martingale. So again, Martingale may not be Markov chain. Markov chain may not be Martingale, but there are some Markov chain which are Martingale. If this Markov chain is a finite state space with this this condition, then this is a Martingale. So what are the other example of the Martingales? So let's close look on this example. The example, let xn denotes the capital of a gambler after time n, and if all bets, so xn denotes the capital of the a gambler after time n, and all bets are fair. All bets are fair. Means the fair means it is a the expected value is 0. Is expected value of 0. That is called fair game. So expect some gambler may lose, gambler may gain, but the expected value of this is 0. So gambler say win 10 rupees for probability 1/10 and lose 1 rupee for probability what 9/10? No, then it is not a. So 9 rupee. So 9 rupee gambler win 9 rupee for probability 1/10 and lose 1 rupee for probability 9/10. Then it is a fair game. So if the bet is like that, you have to choose one digit from 0 to n, and if you win, you will get 9 rupees, and if you lose, you have to pay 1. So that means your winning probability is 1/10, and you will get 9. So 9 into 1/10 plus minus 1, you will lose 1. That means minus 1 into 9/10. Losing probability is 9. So that is 0. So this is called fair game. So in fair game, the expected value is 0. So that's why in the fair game, your capital is, at the n step, your capital is say d or any x. At the n step, what is expected in the n plus 1 step? Again, it is just x, because the next step, the expected gain is 0 because it is a fair. So that is 0 expected gain. Then this xn n greater than 0 forms a martingale. So this forms a martingale. So since it is a fair game. So this is one example. Another example is, consider a Markov chain, and this is not a Markov chain actually. This is a Markov chain. Is gambler after the end step, then bet is fair. Then yes, it is Markov chain. Yes, it is a Markov chain. It is a Markov chain. But the n step, you have a, if you have a say 10 rupees, what is the next step? Your rupees is may not be a Markov chain like that. The problem like that. So example, say it may not be Markov chain. Like if you have a say 5 rupees, what in the previous? No, we can make it a non Markov chain. You can just say we define like that. If you have a 10 rupees now, and if you have a say 7 rupees before, then in next step you will lose 7 rupees with probability half, and you will gain 7 rupees with probability half. So what you are losing or you are gaining, that is say the previous step what you have. So then it is not a Markov chain. Now you have a 10 rupees. In the previous step you have say 8 rupees, and in next step it can be 3 or it can be 13 17 with probability half of. That means the expectation is 0 10. It can be half with half probability 3, half probability 17. So it is expected is 10, but it depends. That is not a Markov chain, because what is the value of the expected value of this? Expected value does not depends on the previous step. Expected value depends only on the x, but what are the value? What may be the value? It's 3 or 17. That depends on the previous step. That not depends not only on the 10. It depends on in the previous step, that is also 7. That depends on the x minus 1. Where x minus 1, what is the value of x minus 1? So we can make it as a non-Markov chain. Same this. So it may not be Markov chain. We can twist, we can modify a Markov chain, we can make it as a non-Markov chain. Okay, so consider a Markov chain. Now consider Markov chain satisfying this. Oh, this is not an example. Okay, you just sorry, it is exercise. Exercise. So consider a Markov chain satisfying this. So it is a martingale satisfying this and having no so it is a martingale having no absorbing state. 0 and D is the absorbing state and no other absorbing state. There is one more extra condition. No absorbing states other than 0 and D. So other than 0 and D, no other absorbing state. So 0 and D is the only absorbing state. So it is a martingale, it is a Markov chain, and it is only absorbing state 0 and D. Then what happened? Then you can show that your 1, 2 up to D minus 1 each lead to state 0. So everyone leads to the state 0. And since 0 is absorbing, from 0 you can go outside, and that's why, and hence each of this 0, 1, 2 or D minus 1 is transient. Why each of is transient? So 0 is the recurrent state. 0 is actually absorbing state. So each of this is transient. What happened if you, what is the contradiction if it is some state recurrent? Then that state will be again it must be absorbing state. So if some state is recurrent, then that must be absorbing state, but it can't be absorbing because it leads to 0, and 0 is again absorbing. So you can just check that this, since the no other absorbing state, this must be transient. What may happen that if say 5 is the absorbing state, if from 5 to 5 it is just probability 1, then 5 is recurrent state, 5 is absorbing, but every state leads to 0. So every state leads to 0 because there is no other absorbing state. Since no other absorbing state, every state leads to 0. Because if some state do not lead to 0, then what happened? Okay, this is homework. We just try to solve it. I'll discuss in the next video, next class. So it is just homework. Think it whether this is why this every state leads to 0 and why this every state is transient. So it's homework. Next thing I discuss in the next class. Next thing is what is expectation of xn starting from x. The condition on x is given that it start from x. So it is y equal to 0 to d y into start from x, the probability of x equal to y. This is a definition. It is unconditional expectation. So y into probability of y, but it start from x. Now what is this? So this is y equal to 0 to d y into the from start from x, it goes to y at the n step. So it is just n step transition probability from x to y. And this you can write as from y 1 to d minus 1. You just break this absorbing state separately. Just take it separately. For 0 it is 0. Y equal to 0 is just 0. For y equal to d, we just separate that case. So what is this? So d into y equal to d. We just take the separate case. For d, for 0 it is 0 into something is 0. So we just, there is now no 0 into something. We no need of writing that. So it is start from 1 to y. You just forget the 0, and for d you just write separately. Now what happened? So this is y equal to 1 to n d minus 1, y p2, that n is transition probability from x to y, and plus what is this? So n step from x to d, it is just start from x, and your that heating time is less than or equal to n. So it's at the n step it goes to a d. That means the heating time at d is obviously less than or equal to n. So it can at n step it is in the n there. So it may be in some previous step it in the d. So heating time is less than or equal to d. Now we have this expected value of xn. Now this is the expected value of xn. Now if you, these are all transient, as in the previous, say consider the previous example, and that from 1 to d minus 1 are transient. This is transient. Then what? Then this tends to 0. We know this tends to 0 as n tends to infinity. We know for the transient state, this tends to 0. X from x to y, the nth step transient goes to 0 for all y 1 to 2 up to d minus 1, because all are transient step. So nth it should be 0. Otherwise, it's already proved in the previous lecture that otherwise if it is not goes to 0, then the sum will be infinite. Since sum is finite, series is finite, the nth term must be goes to 0. Now then limit n tends to infinity, expected value of that xn at starting from x, it is just, we have already p to the that pn xn, that n tends transition probability is 0. So this part is 0, and the rest part is just d into probability of x starting from x. The heating time of d is just finite, so it is less than or equal to n, and n can be anything. So n tends to infinity is a larger n, so that actually means heating time is finite. So that limit n tends to infinity, the heating time is less than or equal to n. Actually, limiting case, heating time is finite. That means it is d into rho x d. So it is just a rho x d. The probability of starting from x and heating time is finite is just rho x d. So this limit is just d into rho x d. Also, what we have? We have this thing, expected value of xn is equal to expected value of xn minus 1 dot expected value of x0. So therefore, what happened? Therefore, expected value of xn, it is starting from x. So starting from x, x0 is x. So that one is x. So expected value of x0 is x, because x0 equal to x is starting from x with probability 1. So x0 equal to x with probability 1, because it starts from x. So this is x. So everyone is so x. So this is all our x. So every thing is x. Every conditional, every expected value is non-unconditional expectation is x. And what happens? So that means your rho x d is just x by d, x by d for x equal to 0, 1 to d. So 0, 1 up to d. So why it is so? It is true for 1 to n, and from d to d, rho, why it is from 0? Start from, it should be 0, start from 1, no? It is start from 0. Start from 0. Yes, start from 0. Going d is 0, obviously. So 0 is the absorbing state. So start from 0, rho 0 d is 0, because 0 is the absorbing state. But d rho dd is 1, because d is the absorbing state. Start from d, it goes to d. The probability of the heating time less than in this finite is this again d, because it's the absorbing state. So rho dd is 1. And other case we already proved for. We actually proved for y equal to 1 to d minus 1, but for 0 and d it is obvious. So for 0 it is just 0 by d is 0. So that means starting from somewhere, that row xt goes to the d, that called is x by d. So as close as you are, as close of your closer of d, that probability will be higher. It's the obvious thing. So d is 100, and you reach to the 100. If we are now in start from 90, reaching 100 is higher probability than start from 80 reaching 100. So start from 80, the reaching 100 is 80 by 100, but start from 90 is 90 by 100. Now again, what we have? Again, we have this row x0 plus row xd is 1. Start from 0 to x and start from 0 x to 0 and x to d is 1, because these two are only absorbing state. Therefore, this implies that row x0 start from x go to 0 is 1 minus x by d. So again, it is a start from d, it is 0. Start from x, it is 1. And other, if it's like a say d equal to 100, so if start from 90, it is 10 by 100. If you start from 50, it is 50 by 100. Start from 10, it is 90 by 100. So this is true for, again, not only for 1 to d minus 1, also true for d, 0 and d. But 0 and d is just a special case. We just prove no need of that previous thing to show for 0 and d. Row 0 0, row d, row 0 d, and row d 0. This is just trivial. There's no need of the previous thing. Since it's absorbing set, that's why it is true. So this is all for Martingale. And next, this video I stop now. This video, and we next class we start from queuing chain. This is one important chain is called queuing chain. So I stop now.